The following example is set up as a slideshow and was one that I originally created for a conceptual physics class, so it's going to kind of look like it's at that level. But as we go through it, I'm going to kind of tie it in with some of these formulas that I've written up here that kind of summarize some of our energy methods, and in particular, it's going to tie in with the concept of mechanical energy conservation and how that can be used to look at things. So let's check it out. It says here. I forgot to read. It says, let's say that last weekend I dressed up as Spider-Man and tried to swing into a window. And then it says down there, for some reason, I decide I want to know how fast I will be going when I complete the swing. And maybe that has something to do with the fact that I completely missed the window and crashed into the wall. Let's say the height change of my swing is 5 meters. So maybe that's an H value, right? Let's say my weight is 500 newtons. That would actually be m times g, right? Because m times g is my weight. That means my gravitational energy is weight times height. 500 times 5 is 2,500 joules. And so I've chosen some simple numbers here so the math is not that hard to follow. My mass, it says, is 50 kilograms. And I think anyone in Physics 2A might recognize that that's not 100% correct, right? Because if m is equal to 50, is m times g really equal to 500 newtons? Well, it's probably a little bit less, right? Because g is equal to 9.81. But you know what? 9.81 is almost 10. So I think I just approximated gravity at being 10 meters per second squared. And that was good enough for this example, at least. So hopefully we can go with that. But based on that, I'm using the formula there. So the formula we have is 1 half mv squared. So far I've used mgh, I've used 1 half mv squared. And I've labeled those as initial energy and final energy. So maybe where I'm going with that is the concept of mechanical energy conservation summarized by E sub I is equal to E sub F. But in this specific situation, E sub I was given by an MGH and E sub F was given by 1 half mv squared. What could we possibly do with that, right? Well, I have this question mark down here because I said I didn't know what my speed is. So that's the thing that I'd like to find. But I'm saying, let's see, I'm saying based on the conservation of mechanical energy, my final energy should also be 2,500 joules. So that's, when I said that, that's really where I'm using this formula now. 2,500 joules is equal to this expression here. So half of 50 is 25 times some question mark number that's squared would give me 2,500. Do you think it might be 10 meters per second, right? Because 10 squared would be 100 times 25 would give me 2,500 joules. So 10 meters per second makes this work. And that is actually 22.4 miles per hour, which suddenly makes me rethink whether I want to do this swing.